On August 26, Russia carried out the largest attack on the critical infrastructure facilities in Ukraine, using more than 100 drones and 120 missiles. The weapons were aimed at energy facilities, water supply facilities, hydroelectric power plants, and even, not for the first time, residential buildings. The attack resulted in dozens of people killed and wounded, and this was in just 8 hours. Moreover, the attack significantly damaged the hydroelectric power plant dam, and its destruction could have killed hundreds and thousands of people. This is a caliber missile. There are the missiles that have been used to fire at Ukraine dozens of times. Over 1,000 of these missiles have been used during the entire war, but only 500 have been shot down. Why? In order to destroy a missile, it is necessary to first find it, and secondly, shoot it down. And the first is where problems arise. To reduce the chance of being detected, the missiles moves very quickly and use extremely low altitudes to fly, hiding behind terrain and other similar structures, because it is this position that is the most difficult for the radar to detect it. The missile simply blends in with the environment, and finally it becomes problematic. There are many examples of such missiles and drones. Ukrainian Maglev 5 Nile drones, American UGM-84 Harpoon and BGM-109 Tomahawk, the Russian rocket caliber and Shahed drones. How can such missiles be found? After all, every missed missile means lost human lives and colossal destruction. But what if we change our point of view? If we can't find a rocket from the ground, shouldn't we try to find it in some other ways? And yes, it's indeed possible. Let's place a radio reflector at a height and distance of several kilometers from the radar, parallel to the Earth's surface, and try to look through the reflector. What will we see? Probably nothing special. A flat reflector with a diameter of 10 meters gives a viewing area of only some 40 meters, which is extremely small. Why? Pay attention to these angles. They define the boundaries of the viewing area. Most often they are adjusted by only 0.51 degree, because the radio reflector is small. In war, it is necessary to make compact, cheap and effective system, and increasing the size of the radio reflector is ineffective and expensive, unless their angles are changed purposefully. The reflector does not necessarily have to be a flat. If we bend the reflector in one direction or another, we can radically change the size and position of the viewing area and turn a 10-meter reflector into an observation area of tens of kilometers. But how we can keep such a reflector in the air? An airplane is very expensive and complicated. A helicopter is even more expensive. And here, airships come to our aid. An economical transport capable of maintaining its position in the air for a long time, and at the same time it's much cheaper and easier to build. This is exactly why we have developed the Bliskavitsa A-type airship. A compact airship with a diameter of 10 meters and a height of 7 meters, with a helium and air balloons installed inside for heating in 215 cubic meters respectively, and also with a variable curvature radio reflector installed at the bottom, which allows you to vary the size and location of the observation zone. And in addition, this airship can be used by several radars at the same time and cover an even larger observation zone. The airship consists of polyethylene terephthalate, carbon fiber based on polyester resins, and metallized film based on polypropylene. It is cheap, simple, and effective means that will help us prevent death and destruction. However, not only death, even in peacetime, the airship can be used as a repeater for civilian drones and other tasks. This is how we make the world a better place. This is how we move the world forward.